Okay, so now Dr. Kern and I are back, and we're going to do example A here, where it says find the slope of the tangent line, m subtangent or f prime of A, for the equation of the tangent line to f at x equals a. So f of x is x squared plus x in this example, so it's a little bit more challenging example than what was done in the book. And we're asked to find this at a equals 1. So just to review, the definition of m subtangent is, or the slope of the tangent line, f prime of a. That's going to be the limit as h goes to 0. It's always important to write down your limit as h goes to 0 of f of a plus h minus f of a all over h. So I like to write down the definition just to remind myself of what I need to do at each step. Okay, so next we're going to plug in a equals 1 in there. And so what is f of x? It's x squared plus x. So I'm going to take the limit as h goes to 0 of x squared plus x. And maybe, just because this is the first time I've done this in a while, I'm going to write down my function with parentheses there to remind myself of what I should be plugging in. So over here, I need to plug in a plus h. Well, a is 1. So I need to plug in 1 plus h everywhere on the left-hand side. And then over here, I need to take minus f of a. Well, a is 1, so I'm going to plug in 1 over here on the right. Okay, so that's the f of a plus h minus f of a is on the top. And then I have just h on the bottom. Does that look good, Dan?
Yep, sounds perfect.
Okay, so now what should we do next?
Well, it looks like to me we should simplify this thing.
Okay, so simplify. I guess to do that, I need to, again, write down limit as h goes to 0. And I need to FOIL that. So that's 1 plus 2h plus h squared. That's this piece right here. And then I need to add 1 plus h. Maybe I'll keep that in brackets just to remind myself that that's the first copy of a plus h. And then over here, I just have 1 plus 1. So it'll be 2, and then all over h. That's kind of okay. Good. All right, so then what do we do? Well, I guess we can.
I think we need to simplify a little more.
Yeah. So limit as h goes to 0 of, now I have 1 plus 1 is 2, 2h plus h is 3h, and then plus h squared. And then I have minus 2 over here, all over h. Okay. And then I guess I can, well, what would be next? I guess cancel the constant terms is what I might do.
And by the way, this is kind of as a hint. You see this a lot with definition derivatives. There's a lot of times where the constants cancel out.
Yeah, that's true. Okay, so now I have 3h plus h squared all over h. And I guess the last thing I could do is factor out an h. You don't have to do this if you can do this in your head, but sometimes it's good to remember. I'm going to factor out an h over h, and then what we're going to do, we're going to cancel that h over h, because remember, h over h is 1, right? So it's the same as multiplying by 1 there. So we end up with the limit as h goes to 0 of 3 plus h, which then when you evaluate as h goes to 0, you get what? 3. Does that look good to you?
3.
Okay.
It looks good to me.
Any other notes you want to make before we sign off?
No, I think it's pretty good. I think this gives everybody a decent idea of how to find a derivative using the definition.
Perfect. Thanks. Okay.